Let's see the next question. Show that the diagonals of a parallelogram divide it into 4 triangles of equal area. So if you consider a triangle ABCD, and now let's draw the diagonals and let the diagonals meet at a point P. Then we are asked to prove that all the areas are equal. That means area ADP and area APB and area BPC and area DPC are equal. And how can you prove that? Well, you know two theorems right now. We know that any two triangles between the same base and same parallel will have equal areas. And we also know that if you have a median like this one, that median would divide a triangle into two triangles of equal area. We have seen that too. Okay, so where can we start with? Firstly, let's consider, say, these two triangles, triangle ADC and triangle BDC. So you can easily prove that they have the same area because they lie between the same base and same parallel. And since DPC is a common area, you can easily see that these two areas are equal. Okay, so here DC is a common base and DC is parallel to AB because these are the opposite sides of a parallelogram, obvious. And so we can say that the area of ADC is equal to the area of BDC. And DPC is a common area, right? So we can split ADC and write area ADC is area ADP plus DPC, and area BDC is CBP plus DPC. And yeah, DPC cancels from both sides and we get area ADP is equal to area CBP. Okay, so we proved that this area is equal to this area. And now let's prove that this area is equal to this area. How can we do that? We'll consider ABC and BDC. In these two triangles, again, you see that BC is a common base and BC is parallel to AD again because they are also opposite sides of a parallelogram. And hence, we can say that area of ABC and area of BDC would be equal. Now again, BPC is a common area. We can split the area as CBP plus DPC and the area of ABC as ABP plus CBP. And you can cancel CBP from both sides and you will get that area of DPC is equal to area of APB. Okay, so we know that these two opposite areas are equal. Now if you could prove that these two adjacent areas are also equal, then this area is equal to this area is equal to this area is equal to this area. Everything is done. So let's try to prove that these two areas are equal. Okay, for that we'll consider the triangle BDC. And in BDC, you see that PC is the median, right? Because DP is equal to PB. Yeah, diagonals of a parallelogram bisect each other. Therefore, this length and this length would be equal. And hence, we can say that CP is a median. And since a median of a triangle divides a triangle into two triangles of equal area, we can say area of DPC would be equal to area of PBC. Okay, so here we have proved that area ADP is equal to CPB. Here we proved that CPB is equal to DPC. And here we proved that DPC is further equal to APB. So from these three equations, we can say area of ADP is equal to area BPC from 1. And area BPC is equal to area DPC from 3. And area DPC is equal to area BPA from 2. So that proves it. That proves that all the four triangles formed have equal areas. And now let's see the next question.